Welcome, chemistry students. You are welcome to the second semester chemistry course, General and Inorganic Chemistry. Unit 5 of this course is on acids and bases. Chapter 5.2 is about types of chemical reactions. In chapter 5.1, we have learnt about different theories on acids and bases. So, we move further now and learn about types of chemical reactions. The instructor for this chapter is Dr. P. Sharada, selection grade lecturer in chemistry, St. Joseph's College for Women, Autonomous, Visakhapatnam. Learning outcomes. By the end of this chapter, the learner should be able to identify the acid and a base in a neutralization reaction, determine the oxidation number of elements in molecules and ions, comprehend the meaning of a redox reaction, understand the role of an oxidizing and a reducing agent in a redox reaction, and also categorize redox reactions into different types based on different criteria. Contents. The contents of this chapter are acid-base reactions, determination of oxidation number, oxidation reduction, and types of redox reactions. Now, we move to the first part of the chapter, which is acid-base reactions. We have learnt extensively about acid-base reactions in the previous video, different theories on acid-base reactions. So, we move quickly here, and acid-base reactions occur between acids and bases. They result in the formation of salt and water that we have already seen. AH is the acid contributing the proton, BOH is the base contributing the OH. Together they form the salt AB along with water, which is the combination of H plus and OH minus. As an example, you can see here hydrochloric acid reacts with sodium hydroxide, then you get NaCl as the salt and H2O as water. So, acid plus base forms salt and water. Now, you can see some examples here. You can see here sulfuric acid plus potassium hydroxide forms. You can see here potassium sulfate along with water, and nitric acid and calcium hydroxide form calcium nitrate and water. Calcium nitrate is the salt. Hydrochloric acid and sodium hydroxide form sodium chloride as the salt along with water. Phosphoric acid and ammonium hydroxide form ammonium phosphate along with water. So, in all these reactions, you can see here an acid reacts with a base to form salt and water. Now, we move to the later part of the chapter. The second part is about determining or calculating the oxidation number of an element in a compound or an ion. What are the different rules that guide the computation of oxidation number? Okay. Now, let us see what is an oxidation state. An oxidation state simply is the charge an atom would acquire if the shared pair of electrons are completely transferred to the more electronegative atom. See, actually covalent bonds are formed by the sharing of electrons, but if you presume that the shared pair of electrons are transferred or moved completely to the more electronegative element, what is the charge this particular atom would acquire is what is called as the oxidation state. It is simply the probable reaction state. Why should we know about oxidation state? Because oxidation state help us to keep track of electrons. You know, where are the electrons, who is giving electrons, who is taking electrons, is there an increase in electron density of an atom due to compound formation, or is there a decrease in electron density due to compound formation for a particular atom of an element. They help us to predict whether an atom has gained or lost electron density during compound formation, and they also help us to establish stoichiometric ratios. Stoichiometric ratios means in the balanced chemical equation we say no, this many moles is reacting with this many moles. So that ratio is called as stoichiometric ratio. Stoichiometric equation is the balanced chemical equation. So oxidation states help us to establish stoichiometric ratios of reactants as well as products in chemical reactions. Now let us look at the various rules that help us in computing oxidation states of elements in compounds. Before we go into compounds, the first rule is that atoms in elemental state means uncombined state. Any atom in its uncombined state will have an oxidation state or oxidation number of 0. Oxidation number is 0 if it is in its elemental state. You can see P4, F2, S8, N2, any element, if it is in its uncombined state means element did not form a compound, then its oxidation number is taken as 0. Suppose you take monoatomic ions. Monoatomic ions means it did not combine with anything, simply the element is existing in its ionic form. For example, Li plus, Al3 plus, Mg2 plus, O2 minus, Cl minus 1, all these are monoatomic ions, Cl minus 1, O minus 2. For such species, charge of the ion is the oxidation number of the particular atom or the particular element. For example, what is the oxidation number of Mg in Mg plus 2 means plus 2. What is the oxidation number of aluminium in Al3 plus means it is 3 plus. What is the oxidation number of oxygen in O2 minus? It is minus 2. Suppose it is O minus 1, peroxides have O minus 1. So then what is the oxidation number of oxygen in a peroxide? It is minus 1. So this is the second rule. The third rule is there are certain elements with fixed oxidation number. It will never change. That is alkali metals. What are alkali metals? In the previous video we saw lithium, sodium, potassium, rubidium, cesium and francium. They will always have an oxidation state of plus 1 only. Alkali metals plus 1. Alkali earth metals, beryllium, magnesium, calcium, strontium, barium and radium. These elements always have an oxidation state of plus 2 only. So fixed oxidation numbers, alkali metals plus 1, alkali earth metals plus 2, fluorine always minus 1. Fluorine will always have an oxidation number of minus 1 only. So these are the three exceptions in whichever compound they may be present. Alkali metals always plus 1, alkali earth metals always plus 2, fluorine always minus 1. Then other rules, oxidation numbers of hydrogen, oxygen and halogens. Hydrogen, oxygen and halogens. Hydrogen we know is always plus 1. But if this hydrogen is combined with an alkali metal to form a binary metal hydride, binary means only two elements will be there in the compound. So if there is a compound between an alkali metal and a hydrogen, you call it as a metal hydride, then hydrogen will get minus 1. Or alkaline earth metal and hydrogen like CaH2, it will always have a minus 1. Boron hydride BH3, then it will have a minus 1. So if it is having binary metal hydrides, only a metal and hydrogen forming a compound, then it will have a minus 1. Generally it is plus 1 only. In binary metal hydrides it is minus 1. Oxygen always minus 2. We have been learning from our childhood. Oxygen always minus 2. But if it is in a peroxide, how is a peroxide bond formed? Oxygen, between two oxygen atoms there will be a single bond. So if it is hydrogen peroxide, sodium peroxide or barium peroxide, if it is a peroxide, oxygen will have an oxidation number of minus 1. Generally it is minus 2. In peroxides it is minus 1. In superoxides like KO2 and RbO2 it is minus half. Look here, oxidation number can be positive, negative, 0 or fractional number. Oxidation state can be positive, it can be negative, it can be 0, it can be a fractional number also. So, this is the case where oxygen is having a negative fractional number as its oxidation state. In OF2, you know, fluorine always -1 kada. We have already learnt that fluorine will have only -1. So, when oxygen is combined with fluorine in OF2, it is +2. O2F2, it is +1 only. These are the exceptions, but generally oxygen will have -2, in peroxides -1, superoxides -half, in OF2 +2, in O2F2 it is +1. Now come to halogens. Halogens other than fluorine. Fluorine is only -1, but there are other halogens. No, we know chlorine, bromine, iodine. So, for other halogens, it is -1 only, but in oxoanions, when the other halogen, chlorine or bromine or iodine, is combined with oxygen to form an oxoanion, and oxyacids, they exhibit positive oxidation states. The positive oxidation states will vary depending on the compound. So, you will get positive oxidation states for other halogens, halogens other than fluorine in oxoanions and oxyacids. Oxidation state of metal, in metal carbonyl, this is also a rule, any metal, if it is forming a metal carbonyl, nickel tetracarbonyl, copper tetracarbonyl, if it is forming a carbonyl, then the metal will have 0 oxidation state. So, metal in metal carbonyl will have a 0 oxidation state. Now, finally, algebraic sum of oxidation states of all the elements in a neutral compound is 0. So, if you are taking a neutral compound like H3PO4, H2SO4 or ammonium phosphate, you take any compound, if it is neutral, not having any charge, then the algebraic sum of the oxidation states of all the elements in the compound should be equal to 0. If it is a polyatomic ion, like like for example CO3 2 minus, SO4 -2 or PO4 3 minus, you are taking ions, polyatomic ions, then the sum total of charges of all the elements in the ion should be equal to the ion's charge. Neutral compound equal to 0. Algebraic sum of polyatomic ion should be equal to the ion's charge, and oxidation number or oxidation state, as I already told you, can be positive, negative, 0 or a fractional number. Based on these rules, in the next slide we will see some indicative examples. You can work out the examples on your own as homework, but for clarity and for better understanding, in the next slide we will work out the oxidation numbers in case of some indicative examples. Let us see. Let us see the oxidation number of carbon in CO2. Carbon in CO2, oxygen is -2. How many oxygens are there? There are 2 oxygens. So, 2 into -2 is -4. We have taken carbon as X. Let us consider oxidation state of carbon to be X. So, because carbon dioxide is a neutral compound, sum total of oxidation state should be equal to 0. So, X plus 2 into -2 is equal to 0. So, X is equal to +4. Oxidation number of carbon in carbon dioxide is +4. Now, let us take the case of sulfur in sodium hydrogen sulfate or sodium bisulfate. You can see sulfur in NaHSO4. This is a neutral compound. So, sum total should be equal to 0. We know hydrogen is +1 because this is not a binary compound, not binary metal hydride kaadu kada. Andukani hydrogen kemo +1, oxygen kemo -2. So, you are having only one sulfur atom. So, we are taking it as X plus 1 into 1. 1 is for the alkali metal. Alkali metals default always will have only +1. So, X plus 1 plus one, you can see here, you can see there are how many hydrogens are there? There are 1 hydrogens. How many oxygens are there? There are 4 hydrogens. So 4 into -2. So 1 for sodium, then you have 1 for hydrogen and 4 for oxygen. Everything taken together is equal to 0. So 1 plus 1 plus x minus 8 is equal to 0. So x is equal to plus 6. Oxidation state of sulfur is plus 6. If you solve it, you will get plus 6 as the answer. Then let us see nitrogen in N2O5. There are 2 nitrogens, means you take it as 2x. Each oxygen is -2. So 5 into -2, 2x plus 5 into -2 is equal to 0, x is equal to plus 5. So oxidation state of nitrogen in N2O5 is plus 5. What is the oxidation state of sulfur in Na2S4O6? If you solve it taking sodium as plus 1, then oxygen as -2, 4x, see 4x, there are 4 sulfur atoms, no? So 4x into, you can see 4x plus 2 into 1, you can see here 4x 2 into 1 plus 6 into -2. There are 6 oxygens, 6 into -2 is equal to 0. If you solve it, you get 2.5 as the answer. 2.5. See, oxidation number can be a fractional number also. So you get 2.5 as the answer for sulfur in Na2S4O6. For the same sulfur in NaHSO4, it is plus 6. See, sulfur is existing in plus 6 oxidation state in sodium bisulfate, and in Na2S4O6 it is existing in 2.5 oxidation state. You take here chlorine in ClO3 -1. So it is X, chlorine is X. So -1 plus 6 is equal to plus 5. That is to say, the oxidation number, you equalize it to the charge, no? We said polyatomic ions, charge of the ion is the sum total of charges of different atoms. What are the different atoms? Chlorine and oxygen. What is the sum total of their charges? Is equal to -1. If you solve it, you will get the oxidation state of chlorine to be plus 5. Only fluorine has a default -1 as the oxidation state. For other halogens, when they are combined with oxygens in oxyacids and oxoanions, you will have variable oxidation states. Here chlorine oxidation state is plus 5. So this is how you will compute oxidation states of different elements in neutral compounds as well as charged ions. Now let us go to the next part of the chapter, which is about oxidation reduction reactions. They are also called as redox reactions. Oxidation reduction reactions are also called as redox reactions. You can see here an indicative picture taken from the internet. You can see here this particular A is having 2 electrons. A is having 2 electrons. B is not having any electrons. You can see here B is plain. After the reaction, the 2 electrons on A are transferred to B. Now B is having the 2 electrons here. Originally A was having the 2 electrons. Now B is having the 2 electrons. So A is getting oxidized. Loss of electrons is oxidation. Addition of electrons is a reduction. So B is getting reduced, A is getting oxidized in the same reaction, which is called as a redox reaction. So in this particular redox reaction, A is transferring its electrons to B. B is gaining electrons. A is losing electrons. A is getting oxidized. B is getting reduced. Remember, oxidizing agent gets reduced. Reducing agent gets oxidized. So, because A is reducing B, A is called reducing agent. Reducing agent gets oxidized. And B is oxidizing A. Why? Because B is taking A's electrons, and so it is causing oxidation of A. So B is the reducing agent, B is the oxidizing agent. So oxidizing agent gets reduced, reducing agent gets oxidized. So this is a very indicative diagram showing oxidation and reduction. A reducing agent gets oxidized and an oxidizing agent gets reduced. You can see some indicative examples of oxidation and reduction here. See, addition of oxygen is oxidation. Removal of hydrogen is oxidation. See, removal of hydrogen means hydrogen sulfide is there. You are getting sulfur as the product. That means sulfur lost hydrogen to chlorine. So, chlorine is getting reduced. Sulfur is getting oxidized. So, you can see here originally chlorine oxidation state is 0. But in the product chlorine oxidation state is -1. That means there is a decrease in oxidation number of chlorine. So, chlorine is getting reduced. Removal of hydrogen. Let us see what is the oxidation state of sulfur in H2S. Hydrogen is +1 means sulfur is -2. In the reactant sulfur oxidation state is -2. In the product sulfur is in elemental state, so its oxidation state is 0. So, -2 becoming 0, sulfur is getting oxidized. So, removal of hydrogen is oxidation. Addition of hydrogen is reduction. Removal of hydrogen is oxidation. Removal of electropositive element is also oxidation. See, potassium iodide. Potassium is the electropositive element. Iodine is losing the electropositive element. Removal of electropositive element is also oxidation. You can see potassium iodide is forming iodine. Means iodine is losing potassium. So, what is happening to iodine? Iodine is getting oxidized. What is the definition of oxidation? Addition of oxygen, removal of hydrogen, removal of electropositive element. You can see here iodine oxidation state here is -1. In the product it is 0. Increase in oxidation state is oxidation, decrease in oxidation state is reduction. So, iodine -1 is becoming 0 means there is an increase. So, iodine is getting oxidized. Let us see chlorine. Chlorine on the reactant side is having 0 oxidation state, but on the product side it is having -1 oxidation state. So, chlorine is getting reduced, iodine is getting oxidized, chlorine is getting reduced. And finally, what is the other definition of oxidation? Oxidation also means removal of electrons. Removal of electron will lead to increase in positive oxidation number. See, you can see here iron is in 0 oxidation state because it is in the elemental form. Zinc is in 0 oxidation state because it is in the elemental form. But if you come to the product side, iron is forming Fe2 plus. 2 plus, there is an increase in positive oxidation state due to the loss of 2 electrons. Zinc is forming Zn2 plus on the product side because of the loss of 2 electrons. So, increase in positive oxidation state or removal of electrons is also oxidation. Now, let us see what is reduction. Reduction is addition of hydrogen. You can see here C2H4 adding hydrogen to form C2H6 is reduction. Addition of hydrogen. Another definition is removal of oxygen. HGO, mercury is associated with oxygen. If you remove oxygen from mercury, mercury is forming elemental mercury which is in 0 oxidation state. So, mercury on the reactant side is having +2 oxidation state. On the product side it is having 0 oxidation state. So, +2 becoming 0 is reduction. Decrease in oxidation number is reduction. So, it is going from +2 to 0. So, mercury is getting reduced. How? Due to removal of oxygen. Another definition is addition of electropositive element. See, removal of electropositive element is oxidation, addition of electropositive element is a reduction. So, sodium is an electropositive element, it is getting added to chlorine to form sodium chloride. So, addition you can see here an electropositive element is added to chlorine to form sodium chloride. So, chlorine is getting reduced. Chlorine on the reactant side is having 0 oxidation state. chlorine on the product side is having -1 oxidation state, which means chlorine is getting reduced. Decrease in oxidation number is reduction. So it is 0 to -1 is reduction. Look at sodium. Sodium is having 0 oxidation state on the reactant side. On the product side, sodium is having +1 oxidation state. So sodium is getting oxidized, chlorine is getting reduced in this particular redox reaction. You can see here, addition of electrons is reduction, removal of electrons is oxidation, addition of electrons is reduction. Two chlorine atoms take 2 electrons to form 2 chloride ions. Formation of 2 chloride ions is reduction. Similarly, Cu2 plus is taking 2 electrons. Cu2 plus is taking 2 electrons to form copper metal, which is reduction. So addition of electrons is 2 plus becoming 0 is reduction. 0 becoming -1 is reduction. So addition of electrons is reduction. So what is oxidation? What is reduction? Oxidation is addition of oxygen, removal of hydrogen, removal of electropositive element, removal of electrons is oxidation. Addition of hydrogen, removal of oxygen, addition of electropositive element, addition of electrons is reduction. Now, and what are the types? We go to the last part of the chapter, and this chapter pertains to different types of redox reactions. Just now we saw redox reaction involves reduction, oxidation simultaneously. Someone gets reduced, someone gets oxidized. You call it as a redox reactions. Both processes occur simultaneously. An oxidizing agent gets reduced, a reducing agent gets oxidized. That also we have seen. Now let us see the different types of chemical reactions. You have learnt about the different types of chemical reactions in your previous classes itself. So chemical combination, 2 or more reactants combine and one product is formed. When 2 or more reactants combine to form one single product, you call it as a chemical combination reaction. C plus O2, CO2 combination. Mg plus O2, MgO chemical combination. Magnesium oxide from magnesium and oxygen is chemical combination. Formation of carbon dioxide from carbon and oxygen is chemical combination. Formation of H2S, hydrogen sulfide, from hydrogen and sulfur is chemical combination. So the first type of chemical reaction is chemical combination. Now let us see the other types of reactions. We have already learnt about the chemical combination reaction, and now let us see the decomposition reaction. See, the name itself indicates it is breakdown of one molecule into 2 or more species is what is called as a decomposition reaction. You can see here water is broken down into hydrogen and oxygen. Sodium hydride, you can see here, is broken down into sodium and hydrogen. KClO3, that is potassium chlorate, is broken down into potassium chloride and oxygen. So breakdown of one molecule into 2 or more species is what is called as decomposition. What is displacement? Name itself is indicating some species is displacing some other species. An atom or an ion is replaced by another atom or an ion is what is called as a displacement reaction. You can see here copper sulfate. Copper is displaced by zinc to form zinc sulfate and copper is liberated. Zinc and hydrochloric acid forms zinc chloride with the liberation of hydrogen gas. Magnesium and hydrochloric acid forms magnesium chloride with the liberation of hydrogen gas. So these are the examples in which an atom is displacing another atom from the particular compound. Then of course, let us go to the disproportionation reactions. These you have already learnt in your intermediate level. These are the reactions in which the same element exists as an oxidized form and as a reduced form in two different compounds among the product. The same element on the reactant side will both get oxidized as well as reduced. Same element oxidized, you can see here phosphorus is in 0 oxidation state, is oxidized to -3 in one compound, +1 in another compound. Similarly, sulfur on the reactant side, 0 oxidation state, is oxidized to +2 state in one compound, -2 state in another compound. So, those reactions in which an element is both oxidized as well as reduced are called as the disproportionation reactions. Phosphorus is reduced here and oxidized here. Sulfur is reduced here and oxidized here. So, such reactions are called as the disproportionation reactions. So, we have come to the last part of the chapter and we now close with recollecting or recapitulating what we have learnt in the video so far. We have learnt that acid-base reactions are also called neutralization reactions and they involve an acid and a base as the reactant and salt and water as the product. So, acid-base reactions result in the formation of salt and water. Then we have learnt that oxidation state is the charge attained by an atom when the shared pair of electrons are presumed. You imagine that the shared pair of electrons are completely transferred to the more electronegative atom. Under such circumstances, the charge acquired by an atom is considered as the oxidation state or the oxidation number. Then oxidation numbers are computed based on a set of rules. You have a set of rules for calculating the oxidation number. Some elements always have a fixed oxidation number. Fluorine always -1, alkali metals +1, alkaline earth metals +2, metal carbonyls, metal will always have 0 oxidation state. So, based on a set of rules, you will calculate the oxidation numbers of elements and after these numbers help us to determine stoichiometric ratios of compounds in chemical reactions. How many moles of reactants, how many moles of products. So, in balancing equations, in determining stoichiometric ratios, the oxidation numbers are used. Then of course, we have understood that redox reactions occur simultaneously. So, reduction and oxidation will occur simultaneously and oxidizing agent gets reduced and a reducing agent will get oxidized in a redox reaction. Then we have also learnt finally that there are 4 different types of redox reactions. What are they? Just now we have learnt that there are 4 redox reactions, 4 types: combination, decomposition, displacement and disproportionation. So, these are the 4 types of redox reactions. Thank you. All the images in this video are sourced from open source public domain websites. Thank you.